Okay. All right. So we should be right here. We're going to be on our last section, systems of inequalities. We're going to start out with just talking about a linear inequality and how to graph that, and then we will work our way towards some of these systems like what we were just working with even on our bell ringer, where you have sometimes a line, sometimes you have a circle, sometimes you have a parabola. We'll talk about these different situations where you have maybe a linear systems of equations and then also nonlinear. With the linear systems, hopefully most of this is review because you have done this before. You did this even way back in Algebra 1. You talked about how to graph an inequality on the coordinate plane. When you have an inequality, that means that there's a less than or a greater than symbol instead of an equal sign. You could also have a less than or equal to or greater than or equal to. And depending on what kind of symbol they give you, that tells you whether your graph should be solid or dashed. So if it's missing the equal sign, when you graph your line on the graph, it should not be a solid line. It should be a dashed or a dotted line. If it does have the equal sign, then it would be solid. All that means is that the points on the line would either be included in the system or they would not be. So if you have just less than or greater than, all the points that make up your actual line would not be considered solutions of your equation. If you do have the equal sign, then it does include those points that would be on the line. So that's really the main difference between those two things. Then what you do to figure out where you're going to shade is you test a point that's not on the line. So like usually I try to do 0, 0 if I can. If the line goes through 0, 0, then I have to pick a different point to test. You plug it into your equation, you see if it's true or false, and that'll tell you whether you shade. If it's true, you shade the area where that point was at. If it's false, then you shade on the other side of the line. Okay? So let's do an example here. We've got 4x plus 2y equals 10. That's our equation. First thing I would do is just by looking at the equation, I know that this inequality sign right here is going to mean I have a dashed line when I graph it. Okay. There's a couple ways that we could graph this. The first method is to use the intercepts. So if you don't want to have to rewrite the equation in slope-intercept form, you want to just use it the way that it's written right now, we can find the intercepts and then graph those 2 points. So remember, to find your y-intercept, that's when you put a 0 in for your x. So on my equation up here, I would put 4 times 0 plus 2y is greater than 10. When you put in the 0, it should get rid of that term. That's kind of why we do that. And so we'd have 2y is greater than 10. If I divide by 2 on both sides, then I get y is greater than 5. And I'm going to think about it right now as equal to 5 instead of thinking about it being greater than 5. This would mean you're at the point 0, 5 on your graph. So on your coordinate plane, you're going to go to the y-axis up 5 and draw a point. Now to find your x-intercept, you put a 0 in for the y. So that one looks like 4x plus 2 times 0 is greater than 10. Again, the 2 times 0 is gone. Now this one, you have 4x is greater than 10, or you're thinking 4x equals 10 for right now. If you divide by 4, it's not going to come out evenly. We get 2.5, but we could still graph that. This time, though, it would be 2.50 because you put a 0 in for the y. You're going to have to estimate where you think that is, but you kind of can stick it in between the squares there and put a point. That's the first way you could graph. That's method 1. If you don't want to do a lot of rewriting, you can just put in zeros for your x and your y and solve for the other letter. When I draw my line in here, though, it should be dashed. So when I connect these, I don't want to see a solid line. You need to have a dotted line here on your graph. Okay, and then we need to pick a point to shade. Because my line does not go through the origin, I like to use 0, 0 as my point to test because it's easy. It's easy to work with 0. So I'm going to put zeros in for both x and y. So I'm just going to write down here, I'm going to test 0, 0. So that would be 4 times 0 plus 2 times 0. Right now we're questioning, is this greater than 10? The whole left side should be 0. So I'm left with this statement. 0 is greater than 10. Is that true or false? It's false, right? 0 is not bigger than 10. So I don't want 0 to be included, which means I want to shade on the other side of my line. So I don't want to shade where 0, 0 is. I want to shade over here. So anything on the other side of that line would be no good solutions. They would not work for our inequality. Like I said, that's one way to solve a linear inequality is to use the intercepts. That comes in if you don't want to do a lot of rearranging of your terms. However, I think a lot of us are maybe used to having to solve something for y, or we've maybe just gotten into that practice where we do write it in slope-intercept form, or we like to graph it in slope-intercept form. So at the bottom of our page here, we have the exact same equation. Okay, 4x plus 2y is greater than 10. But this one is just going to show you guys how would you do this if it was written in slope-intercept form. So this is me solving for y. So the first thing I would do is subtract the 4x. So this would say 2y is greater than negative 4x plus 10. And then we would divide by 2. And so y would be greater than negative 2x plus 5. When you go to graph this, you would start up at 5. And your slope is negative 2 over 1. So you would go down 2 and right 1 over and over again. And then again, I haven't changed anything about the equation. So it's still going to be a dotted line. I can still test 0, 0. And nothing about that's going to change either because I didn't change my equation. So I'm still going to have 0 is greater than 10, which is still false. So I'm still going to have to shade on this side of the line. So my end result is the exact same because I didn't change my equation at all. I just showed you two different ways that you could approach that. Now, if you look at the second one, I didn't have to deal with a decimal. I didn't have to estimate where I thought a point was going to be. So maybe it would have been better if I had just started out with slope-intercept form and graphed that equation because those numbers are pretty easy to work with. However, my lines look the exact same. And even if I kind of look at my dotted line, if I had been really careful and like gotten out a straight edge and everything, I bet I would have gotten it to go through 2.5 there on my x. So it doesn't really matter which method you guys want to use when you're graphing a linear. You can use the intercepts or you can rewrite it in slope-intercept form. Do we have questions though on how to do that? Does that feel familiar to anybody? Maybe a little bit, okay? So we're going to continue with that. So if we guys turn our page, I'm going to give you guys a minute or two here. Go ahead and try to do this. You've got another linear one, and you can choose if you'd rather use intercepts or if you'd rather rewrite it. I'll let you kind of decide what you want to do there and give that a try. All right, I'm going to start working through this. First of all, is this going to be a dashed line or a solid line? Solid, and how do we know that? It's got that equal sign this time. So you should have had a solid line when you graphed this. Now, again, I don't care if you guys used intercepts or you rewrote it. I tend to go for rewriting it in slope-intercept form. So I would have subtracted the 3x. So we would have had 5y less than or equal to negative 3x minus 10. And then I would divide by 5. I can't take negative 3 divided by 5, so I'm going to write that as a fraction, which is okay because I like my slope to be a fraction anyway. And then negative 10 divided by 5 is going to be a minus 2. Really quick, what needs to happen in a problem in order for that sign to have to flip its direction? If you divide or if you multiply by a negative number at any point when you're working with an inequality, remember that the rule says you have to switch your inequality sign. That doesn't happen here, but it could happen when you're working with these on your own, okay? Now, to graph this, I would go down 2, and then my slope is negative 3 over 5. So I would have gone down 3, right 5, or up 3, left 5. So there's some points, and then you would draw your line. It should be solid this time. And now we have to test a point. I would still use 0, 0 if you can. The line doesn't go through 0, 0, so it's free game for us to use. So if I put in zeros for my x and for my y, this all cancels out. So I have 0 less than or equal to negative 10. Is that true or false? Is 0 smaller than negative 10? No, right? That's false. So we do not want to shade on the 0, 0 side. So I want to shade underneath the line this time. So your shading should be down here. All right, any questions on those linears? All right, now we have inequalities with nonlinear equations too. So we're going to talk about these cases next. So you won't always have a line. Sometimes you'll have something that looks like this one. Okay, what kind of graph do we have here? Just by looking at the equation, what is this going to make? A parabola, because it's got the x squared. So we know this is going to be a U-shaped graph. And so we're going to maybe use what we've done in the past to help us graph this. Now, they talk about using the transformation. You could do that. But honestly, if you guys all have your calculator in front of you, you could type this into your table and just make a quick table, probably faster than even figuring out what your transformation would be. And I'm okay with that. So let's go ahead and just make a little chart down here. And I just want you to type into your table 3x squared plus 1. And I just want to know a couple of points, like negative 2, negative 1, 0, 1, and 2. Can you guys tell me what you get? Good. Okay, if you wanted to use the transformations, you would take those like your original graph, like just x squared. The first thing that you could do is you could multiply all of those x values by the 3 to affect like the stretch that's going to happen, and then you would add 1 because it's going to move it all up 1 after you did the stretch. You'd get the same answers as I just got there. Okay, I'm going to go ahead and graph these points. Now I can't fit all of them on here because negative 2 and positive 2 go off my graph a little bit, but I can do the other ones. Negative 1 is at 4. 0 is at 1. 1 is at 4. Okay, now if you really wanted to put those other points on, you could. They would just be up above in your graph. But we should see that our graph's going to go up. When I draw my parabola, should it be solid or should it be dashed? Good, dashed, because I have a less than or a greater than sign here. So this is going to mean dash. And make sure you have it go up. You don't want it to just stop at that point. Okay, we still need to test a point. Again, if I can use 0, 0, I'm going to. This graph does not hit that point, so it's still good for me to use. So So I'm going to put a 0 in for the y and a 0 in for the x. So it's going to say 0 is greater than 3 times 0 squared plus 1. What is this going to simplify to? 1, right? 0 is greater than 1. True or false? False. So I do not want to shade where 0, 0 is. Where would that be at on my graph? 0, 0 is below, right? So where do I want to shade? Inside. So all your coloring should be inside the parabola. All right, let's go to the next one. We're still dealing with a nonlinear. What is this one going to be? A circle. If you look at that equation, it's got the x squared, the y squared. It's got a number on the other side. So first of all, is my circle here going to be solid or dashed when I go to the graph? Solid. Okay, let's talk about what's the center. What did you say, Autumn?
No, I don't know.
No, you do know.
No, I don't.
Yes, you do.
Not confidently.
-2, +5. Remember, your center comes from those parentheses, but it's opposite signs. Because they always start out with a minus. So if it switched to a plus, that means you put in a negative. And then how do we find our radius? What do we do with the last number? Square root it. Because remember, the last number is r squared. So what's the square root of 16? 4. So my radius is 4. So I'm going to go to my graph now. I'm going to go to my center first, which is -2, 5. From that point, we're going to go up, down, left, and right 4 to give us an idea of where my circle's at. We said it's solid, so as I connect, I don't need to worry about having a dashed. That's a pretty good circle, if I can say so myself. Now let's talk about how to shade. Does the circle go through 0, 0? No, so let's use that point. So if I put zeros in up above to that whole equation, I would have 0 plus 2 squared plus 0 minus 5 squared is greater than or equal to 16. How does that simplify? What's the left side going to end up saying? It's not just 0. Because what's 0 plus 2? 2. So 2 squared is 4. 0 minus 5 would be -5. What's -5 squared? 25. Then we would have to add those. So that's 29. Is 29 greater than 16? Yes. So I do want to include 0, 0 this time. So this is true. We haven't had one of those yet come out to be true. So when I shade, you're going to shade on the outside of your circle. So I want everything out here. Make sure you color all that in. We want all that space on the outside of the circle. Nothing on the inside. All right. Do we have any questions so far? We doing okay, everybody? Okay. I think we've got time for one more here today, and then we'll have to probably finish the last two tomorrow. So if we look at this last one, now they're giving you more than one inequality to graph. So we're getting into our systems now. So far, we've just dealt with like one thing at a time. And this is going to be that situation where we could have two linears, we could have a line and a parabola, we could have a circle and a line. Like we could start to combine all of these different types of inequalities with each other. When you are going to graph a system like this, you still need to graph each one individually. And then when we look at the shading, what we're going to end up looking for is where do the pieces overlap. So when you shade for both of your individual inequalities, you're going to be wanting to see where do they share their shading at, and that's going to be your final solution. So I'm going to start by graphing them individually. I've kind of got them split apart here. So I'm going to start with this x minus 3y is less than 6. I'm going to rewrite it for my slope-intercept form. So I'm going to subtract the x first. So we've got negative 3y is less than negative x plus 6. Then you're going to divide by negative 3. But what do I need to be careful of here? Switch your sign. So it goes to a greater than sign now. Now my x was already negative and it's a 1 in front. If I divide that by negative 3, it becomes positive and it's 1 over 3 now x. What's 6 divided by a negative 3? Negative 2. Okay, so there's my equation, y equals 1/3 x minus 2. I'm going to start now by graphing that. So I'm going to go down 2. Then you're going to go up 1 over to the right 3. Should this one be solid or dashed? Dashed, because it's got a greater than sign. Okay, now let's talk about how we're going to shade it. So I can still use 0, 0. So if I put 0 in, it would be 0 is less than, oh, hold on. I want to go back to my original equation up here. So it'd be 0 is less than 6. True or false? True, right? So I'm going to put a T next to that for true. And then that means we shade where 0, 0 is. So we're going to shade up above this line up here. Okay, we're not done though, because we have another line that we need to do now. So I'm going to start again by writing this one in slope-intercept form. What would you guys do first to do that? Minus 2x. And then what? Divided by 3. Do I have to flip my inequality sign this time? No. And this would be negative 2/3 x. What's negative 6 divided by 3? 2. So we start at 2 for this one, and you go down to right 3. Should this one be solid or dashed? This one should be solid because it has an equal sign. Okay, we still have to test a point. I can still use 0, 0 for this one as well because it doesn't go through. Again, if I come back up here to my original, the whole left side, you'd put 0 in for x and y. They're multiplication, so they all are gone. So we have 0 is greater than or equal to negative 6. True or false?
Wouldn't the positive 2 be a negative 2? Because negative 6 divided by 3.
Oh. Yeah, you're right. Okay, let me fix that. Yeah, it should be minus 2 here. Oops. You don't even want to give me an answer. You think you could stand in front and teach if you don't even want to give me an answer?
No, my study would get the best.
Okay, so is 0 bigger than negative 6? Yes. 0's bigger than negative 6.
Oh, yeah, negative 6.
And you think you can teach, okay. So if we say that that's true, we're going to shade over here. Okay, where do they overlap at? Kind of up in this area, right? Like here to here is where their shading is overlapping. So when you have overlapping shading like this, you want to color in even darker on that. So if you're just using pencil, I don't need fancy colors. If you want to use fancy colors, great, but you don't have to. But you should really color in dark where your center or your solution set would be. Okay? All right. Oh, we've got one final question. Hold on, we're not done. There's one little question at the bottom here. Double shaded is the solution set, so we just talked about. Name 2 points that satisfy both equations. So give me 2 points that are in this area that I just went over in pink. Any 2 points. 1, 2. 2, 1. There's a lot of possibilities. Okay, could be anything in that area up there. All right, we will stop here. We are going to finish